Hey, how are you doing? Um, hey, so far the work you've been doing with stoichiometry looks good. Let's look at gas stoichiometry. So we're going to use Pivnert in this case. Okay. So let's think of a reaction that produces a gas. Okay. Sodium azide. So this used to be used in airbags to fill up an airbag. Believe it or not, an airbag has to be filled up within 4 millionths of a second, so that when you hit it, it's starting to deflate, which is crazy. But old airbags used to have this. This was a solid, and it would decompose, of course, into sodium and nitrogen gas. Okay, so let's balance that. We got 3 and 2, so we can 3 it to it. And all right, so let's say this. Let's say we have like 110 grams of this, and we want to figure out what the volume of this gas is. What's the volume of that gas? Maybe you hear my dog, Casey. Okay, so this gas, let's say it's at 22 degrees Celsius and at a pressure of, let's say, 1.4 atmospheres. All right. So, volume. We're going to use Pivnert given temperature and pressure. So we know we're going to use Pivnert. And we know V equals nRT over P. We have our pressure, we have our temperature, we just have to change it to Kelvin. We have our constant, of course. We just need moles. So that's where the stoichiometry comes into play. So what we'll do is we'll convert this to moles and then to moles of nitrogen. So it's going to look like this. So grams of sodium nitride to moles of sodium nitride to moles of nitrogen. So that's the kind of like the path we're taking. Okay, so let's start with 110 grams of sodium nitride. Gotta convert that to moles. Let's quickly figure out the molar mass. So 14.01 times 3 plus 22.99. That's the molar mass. So for every 1 mole of sodium azide, we have that many grams. Okay. Let's use the mole ratio. 2 to 3. All right, think about where's that 2 going to go. The 2's with sodium nitride, so we want that canceling out. So 2 moles of sodium nitride is equivalent, chemically equivalent to 3 moles of nitrogen. So let's just stop here now. So let's get an answer. So let me hit that button, times 110, and then multiply by 3. So think about that. That is 2 sig figs. So let's just use 2 sig figs here. Although we can round off at the end. So let's say it's 2.54 moles of nitrogen, okay? All right, so we're almost there. So then what we just need to do is place that into there. So volume equals 2.54 moles, 0.0821, remember the units? Atmosphere times liter per mole Kelvin. All right, 22, so that's plus 273, that's 295, I think I did that right, divided by 1.4 atmospheres. Okay, so times 0.0821 times 295 divided by 1.4. And now we can round off, and the answer is 44 liters. Hey, that's a gas stoichiometry problem. So, sorry about that. So we did the stoichiometry to get moles, and then we just used Pivnert. Now, there could be also problems where we use Pivnert first, and then we use stoichiometry. So we would use Pivnert to figure out the moles of the gas, and then we'd use the balanced chemical equation to figure out the moles of something else. Don't forget to make sure pressure is always in atmospheres, temperature is in Kelvin, and That's gas stoichiometry. Hey, look out for a worksheet on these types of problems. Okay, thanks.